Hi guys, my name is Peter and welcome to a new video. So in this video, I'm going to talk about VPC, which stands for Virtual Private Cloud. So VPC can be considered as one of the foundational service of cloud computing. So any sort of architecture that we are going to design will be built on top of a VPC. So it's a really important service that any sort of aspiring cloud architect, cloud engineer, or anyone related to cloud should learn about. So in this particular video, we are going to learn in depth about what is VPC and everything related to it. So talking about the agenda of this particular video, first of all, we are going to learn about VPC. We will understand why VPC is important, and also I'm going to provide some real life examples so that you can relate to VPC in a much better way. And after learning a bit about VPC, then we are going to get onto the building part, where we are going to build an architecture entirely from scratch. So here we will be given an architecture like this, and we will be building this architecture in AWS. So don't worry if you don't really understand anything about this architecture now, because I will be decoding this architecture and I'll explain everything in a step-by-step manner. So once that is done, once we build the architecture, then we are going to test the architecture to make sure that the VPC that we have created is basically working based on our requirement or not. And that's it. It's going to be a really exciting video, as well as it's going to be really informative. So make sure that you guys watch till the end. And also, if you guys have got any sort of queries, please do let me know in the comment section, and I'll be more than happy to help. So let's get started. So now let us see what is a VPC. So going through a simple definition, VPC is a virtual network created within a public cloud service provider. It allows to isolate and control the resources within the cloud. So explaining this in simple terms, so VPC is a private network that is created within a public cloud service provider like AWS, Azure, GCP. And we will deploy resources like EC2 instances, databases onto this particular VPC. So the advantage of deploying them in a VPC is that we can completely isolate these resources from the external world. And also you'll be having much more control over these resources when they are inside a VPC. So when creating a VPC, you can define rules like what all traffic can come inside a VPC, what all traffic can go outside a VPC, which overall make sure that the resources inside the VPC are safe. So this is a really simple explanation of what a VPC is. And another thing that I want to bring to your notice is that if you directly go to AWS and launch an EC2 instance, it will be launched inside the default VPC which is created by AWS. So let me show that to you guys. So right now I am in the AWS console, and let me simply go to the EC2 section and try to launch an EC2 instance. So if I click on launch instance here, and if I scroll all the way down in the network settings, you can see a really interesting thing. So I'm going to click on the edit option right over here. So if I don't really do anything and simply launch an instance, that instance will be launched inside the default VPC created by AWS, just like that you guys can see right over here. This is the default VPC created by AWS. So even if you don't really create an VPC, AWS by default has a VPC onto which your EC2 instance will be launched onto. So this is one thing that I want to bring to your notice. So just like that, if I go to the VPC section in my AWS console and go to your VPCs right over here, you can see that there is already a VPC, and this is the default VPC that is created by AWS. So by default you have an VPC. So in this video we will be creating our own custom VPC, and we will launch resources on that VPC and see how things work. So now I'm going to explain VPC with a real life example so that you guys can understand VPC in a much better way. So this is a house plan, and this house plan can be easily assembled to that of a VPC. So if you take a look at here, you can see that in a house there are a lot of places that are publicly accessible as well as privately accessible. For example, the living room is publicly accessible, the kitchen is publicly accessible, the dining room is publicly accessible. But the bedroom is kind of a private place, right? It is privately accessible by selected number of people in your house. So a VPC is pretty similar to that of a private room. So in your bedroom you have got some really important information like documents, money, other credentials, and all these things. So you don't want all of the people, all of the guests in your house to get inside your private room, right? So you can enforce rules. You have the authority to make sure that only selected amount of people can get inside your room. So VPC is also pretty similar to that. You'll be having a private network and you'll be having the authority to permit only certain amount of traffic or people to get inside your private network. So you can kind of resemble VPC to a house plan like this, so things will be much more clear as we proceed. Now let us get on to the building part, where we are gonna create an architecture entirely from scratch. So now I'm going to decode the architecture and explain it entirely from scratch. So this is basically an AWS region, and as we all know, there are multiple regions in AWS. Like in India, we have got Mumbai is a region, Northern Virginia is a region in the US. So all these are kind of regions, and these regions are publicly accessible. Anybody can access a region and deploy or launch instances in this particular region. So also in a region there are multiple availability zones. So there are availability zone A, B, C. Based on region there can be multiple availability zones. So here we can imagine that in our region there are 2 availability zones, and we can basically create a VPC in this particular region. So here you can see that a VPC is created across availability zone. So the advantage of creating a VPC across an availability zone is that even if anything happens to availability zone 1, the resources can be easily shifted to availability zone, or the task can be easily taken up by availability zone. So this can really help in disaster management, or any sort of natural calamity happen to any availability zone, the other one can easily manage. So a VPC can be created across availability zones or within an availability zone, but the best practice is to create a VPC across an availability zone. And here you can see inside the availability zone 1, we create a public subnet and a private subnet. And just like that, in availability zone 2 also we create a public subnet and a private subnet. So this public subnet and private subnet can be kind of imagined as the public places in a house, and the private places in a house. Like dining room can be considered as a public subnet, your room can be considered as a private subnet. So this is the overall architecture that we are going to build in this particular video. So going through a summary of this particular architecture, so we'll be having a public region. Let's imagine that we are going to create this particular VPC in the Mumbai region. So we have got Mumbai as a region, and within Mumbai we have got 2 availability zone, availability zone 1 and availability zone 2, and we are going to create a VPC across these 2 availability zones. And inside each of these availability zones we are going to create a public subnet and a private subnet, and then we are going to allocate resources to these particular subnets. So before moving on, let us imagine that the project manager gave us certain requirements before building this particular VPC, which means that the availability zone 1, as we know, has 2 subnets, the public and the private subnet. So each of these subnets should have the capability to hold at least 256 hosts. And just like that, the availability zone 2 should also have the capability to hold 256 hosts for each subnet, that is public and private. So based on this requirement, we need to allocate the IP address. So allocating IP address is really important, and we need to make sure that the IP addresses do not overlap, and also it should satisfy the given requirements. So now let us see how we can allocate the IP addresses. So here I'm using this particular online tool, which kind of makes the entire process much more easier. So let me reset it. So here we are supposed to provide a network address. You can provide any network address that you guys want. So here I'm going to go with 10.0.0.0 and the mask bit is /20. Then I'm going to click on update, and it automatically gave me a subnet address. So here you can see that 10.0.0/20 can basically accommodate 4094 hosts, but based on our requirement we need 4 subnets, and each of these subnets should hold at least 256 hosts. So I'm going to simply click on divide. Now I have got 2 subnets, and each of these subnets can hold 2046 hosts. Again I'm going to divide it, and now I have 3 subnets, and 2 of them can hold 1022 hosts, and the last one can hold 2046. And I'm going to divide the 2046 subnet, and now I have got 4 different subnets. which I can directly use if I did not have a constraint of having 256 hosts. So I can also use this directly, but the issue is that I'll be having way more hosts than my requirement, 1022, which is almost double or triple than the requirement of 256. So what I can do is that I can simply divide this particular to 1022 host, and now I can have 510. So again, I'm going to divide another 1022 host. So now I have got 4 different subnets, and each of these subnet can have the capability of holding 510 hosts. So if I divide 510 again, you can see that it becomes 254, and our requirement is to have 256, which goes below our requirement. And also 2 addresses, one will be also reserved, one for network and another one for broadcast. So it would be less than our requirement. So we can't really go with 254. So I'm going to join them. So 510 is the value that we can go for. So we can easily make use of these 4 IP addresses for our VPC. That is, these subnet addresses can be made use while creating VPC. So one of the advantage of making use of a tool like this is that we need not really spend a lot of time manually writing IP addresses. And even if you manually write IP addresses and allocate them, there can be issue of overlapping. So with this tool, you can easily see how many hosts will be there in a particular subnet, and you can simply make use of that IP address to create a VPC. So if you are an absolute beginner and if you don't really know about CIDR blocks or VPCs, IP addresses a lot, this can be a bit confusing. So I suggest you guys to slightly research a bit your own on IP addresses. So if you want, I can also make a simple video regarding CIDR annotations and how we can create IP addresses like this. You can comment down if you want me to make a video like that, and I'll be happy to make one. So now we have allocated the IP addresses based on our requirement, and now let us build our VPC. So right now let's go to the AWS console, and I am in the VPC section. So you can simply search for VPC and come to this particular page. And here I'm going to click on create VPC option right over here. And here you can basically choose 2 different ways to create a VPC. The first one is VPC only, and the second one is VPC and more. So the main difference between these two are, in the case of VPC only, you need to create everything manually. That is, you need to create VPC independently, subnets independently, internet gateway independently, and even if you need to use a NAT gateway, you need to create that also independently. So everything is kind of created as a separate service. But in the case of VPC and more, you can create everything within a single page. So I believe that most of you guys are beginners. So for this video, I think that VPC and more will be much more easier to understand. So let's go with that. So the first thing right over here is to provide a name for our VPC. So I'm going to name it as my-VPC. Alright. And then we need to provide the IPv4 CIDR block. So this is the main IP address of our entire VPC. So if we go to our subnet calculator, this is our main address. So that is 10.0.0.0/20. So this is our main CIDR block address. So I'm going to copy it and I'm going to paste it right over here. And our mask bit is /20. And as you can see that a total of 4096 IPs can be created with this entire IP address. So if we scroll down, so IPv6 CIDR block is turned off. So the tenancy is default. So you also can choose dedicated, but if you choose dedicated, an entire hardware rack will be dedicated to your VPC, and it is going to cost a lot of money. So unless and until you have a requirement of having a dedicated server rack, stick with the default tenancy. So now we need to choose the number of availability zones. So based on our architecture diagram, you can see that there are 2 availability zones, availability zone 1 and availability zone 2. So if you take a look at the region, I am actually creating this particular architecture in the Mumbai region. That is Asia Pacific AP-South-1. So this is a region that I'm creating this VPC in. So here I want 2 availability zone. If I click on customize AC, I can choose the availability zone that I want. So now I'm going with the default one. That is the availability zone 1 is AP-South-1A, and the availability zone 2 is AP-South-1B. And now I need to choose the number of public subnets and number of private subnets. So based on our architecture, you can see that there are 2 public subnets and 2 private subnets. So I'm going to choose 2 for both of them. And now here I can customize the subnets CIDR block for the public subnets as well as the private subnets. So here you can see that by default AWS based on our main CIDR block right over here, they kind of calculated a subnet CIDR block and gave us some values. But here you can see that only 256 IPs are available, and from this 256, one IP address will be used for network and another one is used for broadcast. So in essence you will be having only 254, but based on our requirement we need to have at least 256. So we can't really go with the default address that AWS gave us. So we are gonna go with the subnet address that we have calculated. So I'm gonna copy the first address right over here. Let me copy it and let's paste it right over here. So now you can see that 512 IPs are available. Out of this, 2 will be gone, as I said before. So we'll be having only 510 in the end. So the first public subnet CIDR block is filled in. Now let's enter for the second public subnet. So I'm going to choose the second one. Never reuse any IP address. So I have used the first one, so now I'm going to not use it anymore. Now I'm going to select the second one, copy it and paste it into the second public subnet. Alright, now I'm going to copy the third one from here and paste it right over in the first private subnet. So I'm going to copy the fourth one and I'm going to paste it right over in the fourth private subnet, that is the second private subnet. Alright, so now we have provided CIDR block for each of the subnet, that is for 2 public and 2 private. Now the cool thing about VPC and more section is that AWS provides an amazing preview of what is happening right over here. So you can see that we have created our my VPC, and then we have got 4 subnets. So 2 subnets are in the AP-south-1A availability zone, one public and one private, and in the second availability zone we again have a public and the private. Now you can see that the public subnets are connected to a public route table. So you can see that both of the public subnets in both availability zone are connected to a public route table, and they are in fact connected to an internet gateway. So in fact the public subnets can easily communicate with the internet. That is what is the meaning of having an internet gateway. And the private subnets are not connected to any sort of internet gateway. They are simply connected to a route table, and these private subnets can communicate internally with other components in the VPC. So they can't really connect with the internet. So if they want to connect with the internet, you need to add a NAT gateway, but we are not going to do that in this particular video, maybe in a later future video. So here you can see a clear pictorial representation of the entire architecture that we have created till now. Now moving on, if you scroll down, so we are not going to create NAT gateway as I said now. So that is none. So VPC endpoint also I'm going to tick it as none. So rest everything I'm going to leave as it is. So based on our architecture provided, we have created our VPC and everything is looking perfectly fine. So now let's click on create VPC and wait for. So I think that we are having an overlap. So let me see what's the issue. Okay, so let me copy it and paste it once more. Sorry, so here you can see that these 2 IPs are same, so that is a mistake from my side. So let me copy it once more and I'm gonna paste it. So there was an issue with me copying the IP address. Otherwise I think that now everything is unique. Yeah, now let's click on create VPC, and just like that AWS is going to create a VPC, subnet, internet gateway, route table, everything for us. And if I click on view VPC, this is our VPC. You can see all these representations and everything is looking perfectly fine. So if I click on your VPCs right over here and if I refresh, you can see that our VPC is right over here, and this is not the default VPC, and this one is the default VPC that is created by AWS. Alright, so if I go to subnets right over here, and if I kind of filter it via VPC, and I guess this is my VPC, right? Yeah, this is my subnet. So you can see that 4 subnets are created. If I extend it, you can see that there are 2 public subnets and just like that we can also see 2 private subnets, and they are also in the different availability zones, that is within 2 availability zones. So we have created a VPC. Also subnets are automatically created, route table has been automatically created, internet gateway has been created. So based on our architecture provided, we have successfully created an VPC, and I really hope that you guys understood the entire process behind creating this VPC. And now we are going to allocate some resources to this particular VPC. So the main reason for doing that is that we need to understand the difference between having a public subnet and a private subnet. So we are going to allocate some resources to both public and private subnets and see how things differ. And also we are going to test if our entire architecture is working as per our requirement. So now let's do that. So let us move to the AWS console, and I'm going to open up EC2 Instance section in a new tab. And also let me go to the VPC section right over here, so that we can confirm if the things that we are doing is correct or not. Alright, so let us take up this resource map right here, and now let's go to the EC2 section. Then I'm going to click on launch instance. So before moving on, let me give you guys a brief idea regarding what we are doing. So here we are going to launch 2 instances. One instance will be in the public subnet of AP-south-1A, and the second instance will be in the private subnet of the AP-south-1A availability zone. So 2 instances, one in the public and another one in the private subnet. So here I'm going to provide a name. So the first one will be in the public one, AP-south-1A. So I'm going to name it as 1A-public. Alright. Now the OS that I'm going to use is Windows. So the AMI that I'm going to use is going to be 2016 base. So you can choose anything that is free tier eligible. And instance type is going to be T2 micro. Key pair login is going to be I don't think I have one. So I'm going to create a new key pair .pm. I'm going to name it as AWS tutorial, and I'm going to click on create key pair. Alright, that has been created. Now the network setting is the most important part, so I'm going to click on edit right over here, and here you can see that by default AWS has selected the default VPC, but we want this instance to be launched in our own VPC. So I'm going to click on that, and here I'm going to choose our VPC that we have created just now. And after that we need to choose a subnet, that is which subnet do you want to launch this instance onto. So as we discussed before, we are going to launch it in the public subnet of this particular region. So again I'm going to click on the subnet, and we want that in the public subnet of AP-south-1A. So I'm going to click on that, and here auto assign IP, and to turn it on. So the reason by turning this on is that, so you'll be having hundreds of machines in this particular subnet, right? And this subnet is connected to the internet gateway. So if you take a look at the source map, you can see that the public subnet is actually connected to the internet gateway right over here. So each of these instances that you are going to launch in this particular subnet will need to have an IP address so that it can connect to the internet. So by enabling this particular auto assign public IP, so AWS automatically assigns an IP to the instance and it can be connected to the internet. So that is why we are enabling that. And other thing that I'm going to remain, all of those things are going to remain the same. So type is going to be RDP, so port number is going to be 3389 because we are going to use RDP to log on to this particular server, so we need to have that. And all of the other thing are going to be the same. So let's simply verify the VPC section once more. So the VPC is our own VPC, so the subnet is the public one subnet into the AP-south-1A availability zone. Alright, now let's click on launch instance. Alright, so if I go to instances, it is being loaded. So let's create another instance. So the naming is gonna be private 1A, 1A dash private. Alright, so again the OS is gonna be Microsoft Windows, and the AMI is gonna be 2016 base. So instance type is gonna be T2 micro. The key pair is gonna be AWS tutorial. So the network settings, I'm gonna click on edit and choose the VPC as our own VPC that we have created now, and the subnet is gonna be 1A private. So this is the subnet, that is private 1 AP-south-1A. And here I'm going to disable the auto assign public IP, because these instances in the private are not connected to the internet gateway. As you can see right over here, this is not really connected to the internet gateway. This is just connected to the route table, right? There is no connection to the internet gateway, so there is no point in having the public IP. But the reason for having an option to enable the auto assign public IP is that in certain cases you want the instances or servers in the private subnet to have internet. In that case, you need to use a NAT gateway. I think that I briefly discussed about NAT gateway in the VPC section, but there is an option to have internet connection to the instances in the private subnet. In that case, you can use NAT gateway, and in that scenario you can enable auto assign public IP. But in our case, I'm going to disable it, and the rest of the everything I'm going to leave it as it is. So let me verify the VPC section once more. So custom VPC subnet is private 1 in the AP-south-1A. Alright, now let's launch the instance. Alright, so if I go to the instances, you can see that we have got our 1A- public and 1A- private. So we have successfully launched an instance in this particular public subnet and this particular private subnet. Alright. So now what we are going to do is going to be pretty interesting. So what we are going to do is that we are going to access this particular public server. So I have selected that, and I'm going to click on the connect option right over here, and I want to connect it via RDP client. So I'm going to select that. So here, first of all, I'm going to download the remote desktop file. Then I need to get the password. So I'm going to click on get password, and I need to upload the private key. So I'm going to click on that. And I think that it should be here. Yeah, AWS tutorial.pem. I'm gonna open that, and here I'm gonna decrypt the password. Alright, now here I have got the password. Now this is the RDP that I have downloaded, so I'm gonna click on that. So the username has automatically being filled in. I need to fill in the password. So I'm gonna copy the password from here, and I'm gonna paste the password right over here. And I'm going to click on continue. Click on continue again. Now my local machine is connecting to this particular server, and as you can see that the server is being opened up right over here. So if you don't know, I'm basically using a Mac OS system, and what is loading right now is basically a Windows machine that is 2016 base. So let's wait for this particular system to be initialized and to be set up, and just like that I have got a Windows machine right over here. So let me refresh. So if you don't know what is happening now, we are currently inside this particular instance. We are currently inside the instance that we launched inside the public subnet. So if you take a look at right over here, we are having internet access. So let me verify it by simply going into Internet Explorer, and let us search for something right over here. Okay. I'm going to simply search for Wikipedia. I think that I have made a typo in the Wikipedia's spelling, but I think that it should be fine. Yeah, it's working, and the internet is also pretty fast, because AWS data centers are pretty fast in their internet. Yeah, Wikipedia is right over here. So with this we can confirm that the instance that we launched in the public subnet has internet access, and things are working perfectly fine. And now you might have another question in your mind: how can I access the instance that we have launched in the private subnet? So if I click on the private instance right over here, you can see that there is no public IPv4 address, which means that we cannot directly access this particular machine just like we did with the machine in the public subnet. You can really access it like that. So the only way in which you can access this particular server or instance in the private instance is by using any other machine in the VPC. So for example, this machine in the private subnet can be accessed by this particular machine in the public subnet, or else any machine within this private subnet can also access other machines within them. So the only possibility is that for us right now is that we can use the machine that we have launched in this particular public subnet to access this particular instance in the private subnet. So the way we are going to do is that we are going to click on the connect with the private instance. Again, we are going to click on RDP client. We're going to download the remote desktop file. That is not really necessary, but let's have it. Then let's click on get password. I'm going to upload the private key. Let us decrypt the password. So now let me close it. And now what I'm going to do is that I'm going to access RDP in this particular server. So this server right now is in the public subnet, right? The server is right now here. So I'm going to use this server to access the server or instance in this particular private subnet. So that is what I'm going to do. That is what I'm going to do. I hope that you guys got the idea regarding what we are doing. So here I'm going to search for RDP right over here. It takes a bit of time. Let's wait. I don't think that RDP is installed here. Yeah, it is right over here. So let's click on that. So here we need to enter the IP address. So let us go to our instance. I'm going to copy the private IP from here and I'm going to paste it right over here. And also I'm going to copy the username from here and I'm going to paste it right over here. And let's click on connect. Now I need to enter the password, so I'm going to copy the password from here and I'm going to paste it right over here and I'm going to click on OK. And now this particular server is connecting to the server in the private subnet. I'm going to click on yes. Alright, now you can see that a tab right over in the top, which means that we are currently inside the private subnet. I guess I can move it around. Yeah. So the thing that happened right now is that using a server in the public subnet, we accessed a server in the private subnet. So now we are in the server inside the private subnet. So I click on no, and right here we can notice that there is no internet access, because we know that the private subnet is not connected to the internet gateway, so there is no way in which this private subnet or the server inside the private subnet can connect to the internet. And just like that, we don't have internet access. So let us verify that by simply going on to the Internet Explorer and let's search for Wikipedia and see if it is working. Okay, so nothing is actually loading up. I don't think that I can search for anything. It's taking a lot of time. I think that you guys by now got the idea that this particular system or instance do not have internet access. So you might think that what is the use case of having a private subnet and a public subnet, all these things. So you can see that the page can't be displayed, the internet is not really there. So the main reason of having a public and a private subnet is that especially when you take a case of a software, you can see that the most of the front end part of the application can be deployed onto a public subnet, whereas the databases and other other instances or servers that hold credentials or valuable information can be stored or deployed inside a private subnet. You can see that only the system inside the public subnet can access the server inside the private subnet. No one else can access it. So by this, you can kind of have a higher layer of security, and you can isolate the data inside the private subnet in a much secure manner by having it deployed in a private subnet. So these are some of the use cases of having a public and a private subnet, and I really hope that you guys got a really good idea regarding what is VPC. So in this video we have learned about VPC, we have implemented an architecture of VPC, we have deployed resources inside the public and private subnet of the VPC, and we have also seen a practical demonstration or testing of how entire thing work. So I really hope that you guys got a clear idea regarding the entire virtual private cloud. So I think that is it for this particular video, and as I said before, if you have got any sort of queries, do let me know in the comment section and I'll be more than happy to help. And also do leave a feedback of how do you guys feel about this particular video or anything that I want to improve, and I'll be more than happy to change. So once again, thanks a lot for watching, and I'll see you guys in the next video.